In this example, we have two functions, two rational functions. One is f of x 11x plus 12 over 13x plus 14, and the other one is g of x equals negative 14x plus 12 over 13x minus 11, and we want to find the composition of these two functions, FOG of x and also GOF of x. So we start with FOG of x, which we know it is actually f of g of x. Okay, so this means we are finding f of negative 14x plus 12 over 13x minus 11. So we start from the side, we substitute for g of x, and now we need to find f of this big rational function. So we are going to substitute this big rational function instead of x in the equation of f of x. So it's going to be a big expression. We have 11 times this expression plus 12 over 13 times the big expression plus 14. And the big expression is negative 14x plus 12 all over 13x minus 11. We do the same thing in the denominator. And now all we need to do is to simplify this big expression. We have a common denominator in the numerator, which is 13x minus 11. So we will end up with 11 times negative 14x plus 12 and plus 12 times 13x minus 11. Okay. In the denominator, again, we have the lowest common denominator, which is 13x minus 11. So it will be 13 times negative 14x plus 12 and then plus 14 times 13x minus 11. So we can simplify by multiplying the numerator and the denominator of this huge expression by 13x minus 11. We can cancel the denominators. So we will be left with only the numerators, which we can simplify at the same time. 11 times 14 is 154. So negative 154x. 11 times 12 is 132. So plus 132. 12 times 13 is 156. So plus 156x. And 12 times negative 11 is actually negative 132. The denominator is gone, as we said. In the bottom, we have 13 times negative 14. The answer is negative 182x. And then 12 times 13, which is 156. And then we have 14 times 13, which we just said it was 182, but this time plus sign with positive sign. And then minus 11 times 14 is 154. So this is what we end up with. Continuing to simplify, let's see what we get here. I believe 132 and negative 132 cancel out each other. 156x minus 154x, you can collect like terms. It is going to give us 2x. In the denominator, 182x, negative 182x cancel out each other. 156 minus 154 is what we have. And that would give us 2. So we end up with x when we simplify. So the final answer to FOG, so I'm going to say, therefore, FOG of x is equal to x actually. Okay, so we found FOG of x. It was a simplified answer. Nobody would believe that such a big expression, such a complicated, rational expression would simplify to simply x. But it did. Now to find GOF of x, so we're going to start from scratch. This time we're going to say this is G of f of x in reality. So that's G of, substitute f of x, which is 11x plus 12 over 13x plus 14. It's an interesting function, 11, 12, 13, 14. So now we will see how we can continue. So what we should do, we have to substitute this rational expression instead of x in the equation of f of x. Sorry, in the equation of g of x. Okay, so g of x is right there. So I'm going to draw a big expression. Denominator is 13 times. Now we have to write this expression instead of x, and then minus 11 in the numerator. Similarly, instead of x, we plug in this big expression plus 12. So 11x plus 12, 13x plus 14, and there you go, 13x plus 14. Okay, so now we're going to simplify this expression. The lowest common denominator in the numerator is 13x plus 14. So I'm going to rewrite that. And then we're going to have negative 14 times 11x, which is negative 154x. And then we're going to have negative 14 times 12, which I'm doing the distributive of in one shot. Okay, and then we're going to have plus 12. So this is a plus 12 times the denominator, which was 13x plus 14. Okay, in the bottom we have 13 times 11x plus 12, and then minus 11 times 13x plus 14. The denominator is still 13x plus 14, which can be cancelled out from top and bottom after we multiply the numerator and the denominator by 13x plus 14. So let's see what we get in the top. We have negative 154x minus 168, and then we have plus 12 times 13x, which would be 156x. Okay, and then 12 times 14, which is 168. There's no room. 168, I write at the top. In the bottom, we have 13 times 11, which is 143x, plus 12 times 13, which is 156. Then we have 11 times 13, which is 143, negative 143x. And finally, 14 times negative 11 is negative 154. Okay, so I write the continuation here. We have positive 168, negative 168, they cancel out each other. So we have 156x minus 154x all over the denominator, 143x with negative 140x, 3x each other. So we have 156 minus 154. So that will be 2x over 2. And once again, we end up with x. Simplified answer. Therefore, we're going to say that GOF of x is also equal to x. So we conclude in this exercise that FOG of x is equal to GOF of x. So we know that, generally speaking, these two are not the same. So I'm going to write down here, in general, FOG of x and GOF of x are not the same. But in this case, they happen to be the same. So something is going on. And what is going on here, I'll let you know. I say if g of x equals to the inverse of f of x. So this is inverse of f of x. If that is the case, if in a special case, one function happens to be inverse of the other function, then in that case, both of these FOG and GOF are equal to x. Then I can say FOG of x equals GOF of x, and they're both equal to x. Okay? So generally speaking, we can conclude that f or f inverse of x, which means the composition of any function with its inverse, equals f inverse O f of x, and that is always equal to x. So once again, generally speaking, composition not, I repeat, not commutative, which means that FOG of x is not equal to GOF of x. But in special case, if one of the functions is inverse of the other, like in this case, f of x and g of x are inverse of one another, believe it or not. We didn't know that before. Now I reveal the secret. If that is the case and one function is inverse of the other, in that case, the composition of the two functions will always be equal to x. And it would be commutative in that case, and you can say that f of g is actually equal to g of f of x, as we saw in this exercise. Okay, thank you very much.